Hello class, today we're doing lesson number 7, Distance, Rate, and Time, chapter 5, Equations in One Variable. And we're in a lesson where we're going to see algebra take on a very practical application, particularly as it relates to these three variables, distance, rate, or time, and the relationship they have to one another. And if you have two, you can always determine the third. So let's start reading at the top of the page in the illustration. It says, this is a homework problem. If Mr. Jones travels at 50 miles per hour in a 70 mile per hour zone, how long will it take to get to Cleveland if he has a 22-gallon gas tank? What did you get? And he says 14 hours and 23 square minutes. And the dog who's talking to him, of course, cartoon, says, that sounds right to me. Well, the truth is, first off, you don't measure the time or by square minutes, and obviously there are some issues here. So let's go ahead and read on, and we're going to see here. It isn't possible to solve the homework problem described in this cartoon with the information given. Instead, instead of being told the speed limit and the number of gallons that Mr. Jones' gas tank will hold, we need to know how far it is to Cleveland. Now, if something moves at a constant speed, there is a simple relationship between the distance it travels, its speed, and the time it takes to travel that distance. And when we read these words, we're going to have to pick up on what's being said. Something is moving at a constant speed. Okay, that's the first bit of information we need to understand. So it's a constant speed. And if it's at a constant speed, there is a simple relationship. Relationship is now going to denote, in this particular case, an equal sign. Some things are equal to others. There's a relationship to one another. And those three components are distance, the speed, which is rate, and also the time that it takes to travel that distance. Now, suppose, for example, that Mr. Jones traveled 50 miles per hour for 3 hours. We could see that little illustration over here on the left side, 50, 50, 50. So he traveled 3 hours, so we have 3 different segments at 50 miles per hour. Okay, and a speed of 50 miles per hour means that he travels 50 miles in each hour. So in 3 hours he travels 3 times 50, or 150 miles. Now we can read here that the distance traveled by something moving at a constant speed is, and here's our equal signs, that's the relationship. So the distance is the product of the rate of the speed and the time traveled. This relationship is often expressed by the formula d is equal to RT. So let's go ahead and just put that up here on the board over here. I'm just going to put it up on the top right. D, distance, is equal to the rate or the speed times time, the time that it's traveling. And remember that this is a constant speed. So in this particular case, we can see that 3 times 50 is equal to 150 miles, right? It was traveling at 50 miles per hour, and it traveled for 3 hours. And that means it traveled a distance of 150 miles. So, suppose that Mr. Jones decides to travel at a speed of 80 miles per hour and that he covers 16 miles at this rate before being stopped by a highway patrol officer. How many minutes did he travel before being stopped? So now we're trying to determine the time. We have distance and we have a rate. The distance was 16 miles and the rate was 80. So we have 2 bits of information. We need to determine the third. Now, for the formula, or from the formula d equals RT, we can write the equation, and let's write that 16 over here is equal to 80t. So 16 being the distance that he traveled, 16 miles, and he traveled at 80 miles per hour, and then he was stopped. He was stopped by a patrol officer, well, because he was traveling too fast. Now, we need to now solve this for t. We need to understand that we have to do the things that we've been learning in the previous lesson. And we can solve for t by dividing each side by 80. Now, how did we determine that? Well, we're multiplying t times 80, and we know that we're going to do the inverse operation. We're going to divide by that same number. And the reason being, as we'll see again, and we've discussed this in the previous lessons, is that 80 divided by 80 is now 1. So now we know that 80 divided by 80 is going to be 1t, or the letter t. The question is, what do we have on the other side? Well, it's 16 divided by 80, and if we just simply did our math, divided 80 into 16, and if you wanted to do it on a calculator, that's perfectly fine. The answer would be 0.2. Okay, so that means he traveled at this rate. The time was 0.2 hours. Now, 0.2 hours is not something that we would see on a clock. We normally see hours and minutes, but we know that 0.2 is a fraction of an hour. Now, what do we know about how many minutes are there in an hour? Well, we know there's 60, so we can then just turn this into a simple mathematical function multiplying. It's 0.2 times 60 minutes, and that will allow us to determine in a let's say in a term that we would better understand. 0.2 hours might force us to wonder, well, 0.2, that's 1/5. If you knew your fractions well enough, that's 1/5 of an hour. But if we simply multiplied these two, we would get 12 minutes, which is 1/5 of an hour. But this language would be a lot more common, a lot more easy to understand for us, and we'd say he actually traveled for 12 minutes. Now, suppose that having received a ticket, Mr. Jones slows down, which he should have, and takes 90 minutes to travel 81 miles. Okay, if he travels at a steady rate, what is his new rate of speed? And from this formula, d equals rt, we can write that. Well, let's go over here, go back at the top of the page, and we know that he traveled a distance of 81 miles, that says. Let's put the 81, and that's going to be equal, again, distance is equal to the rate times the time. We do not know the rate, but we know the time. Okay, so there's our r, and the time was 1.5, or 90 minutes, which is 1.5 hours. Again, we'd have to convert the time back to hours. He traveled 90 minutes, and we know that there's, let's see, 90 divided by 60. Wouldn't we do that? And that would give us how many hours? And that would be, well, 1.5, because I know that would be 60 goes into 90 once. There would still be 30 left. 30 divided by 60 would be a half, so that's 1.5 hours. Okay, 1.5 hours. So let's put that in here. Now we're multiplying r times 1.5, and again, we've already says if you want to find the speed in miles per hour, we must express this time, 90 minutes in hours. Now, solving for r, we would have to divide both sides by 1.5, right? Again, why would we do this? Is simply because we're multiplying r by 1.5, so we do the inverse operation, and it's dividing by 1.5. And just to reiterate again, what we've learned in the previous lessons is that whatever you do to one side of an equation, you just simply do to the other, therefore maintaining the balance here of our scales. You're doing from one side to the other. And what we now have is r is equal to, remember, 1.5 divided by 1.5 will leave us with r, simply because that's a 1. And if we divide 1.5 into 81, we would have 54. Now, Mr. Jones' new rate of speed is 54 miles per hour. Okay, and we can certainly write mph as the unit, and we'll discuss that further along. Units very important, and sometimes the units in themselves will tell us if we're doing our math correctly, if we understand how to handle the units. Something which you should have already covered in math as you came into algebra, but we will discuss that little by little throughout the year as well. So that's the end of this lesson, and we'll have an exercise video for you available as well.